So before we start, I have a question for everyone. Who knows Rudder already? Yeah, 1, 2. Okay. So for the other, you will discover what it is and why we made that. Let me introduce myself. My name is Nicolas. I'm one of the co-founders of Rudder. We've been working on this project since 2011. And our goal is still to make configuration management and security of system easier. And I will show you why and how. So this is how we present Rudder now. This is the actual sales slide from our salespeople. Rudder is a system infrastructure automation platform to ensure and improve security posture. It's designed for ops, and it allows you to implement and maintain your security model. So it has 3 parts. I added an open source sign on the part which is open source, which is security configuration management, and I will only speak about that during this presentation, only about the open source part. Hi. So Rudder has an open core license. We are using the GPL v3 license, and most of Rudder is open source. The web interface, the Linux agent, the binaries, API, user authorization, etc. And we provide packages for the main distributions. Some plugins and older operating support are open source, but we don't distribute the binaries freely. And we won't talk about that. And we have some closed source plugin within for Rudder, but we won't speak about that during this presentation. So I will only speak about the open source part of Rudder. So within Rudder, what we do is managing nodes. So a node is a system where you install a Rudder agent. We do need an agent to run and manage the system. So it means we need an operating system already to install the agent on it. And it needs to talk to the Rudder server. So when we install an agent, it registers to the Rudder server with its inventory, and then it can be classified automatically within groups. So the groups are created within Rudder based on queries on inventories. So you can query basically virtually everything in your inventory. So operating system name, the host name, the IP address, the moon point, the software that are present, etc., etc. We define states in Rudder, so we call them policies. We have a multi-layer system to create these policies. They can be either in audit mode or in enforce mode. So audit, the agent will only check, as you can guess, and enforce, the agent will check and remediate automatically if it's not correct. When we define a state, it's a bit like in a playbook. We have our YAML, and we define what it does. But we don't include the targets. The targets are based on the groups. So it's the combination of the states and the groups, which make what we call the rules. We can create as many rules as we want. The nodes can be as many groups as they need. And the Rudder server computes what are the policies for the nodes. The agent fetches them, applies them, return the feedback on the Rudder server. And the Rudder server computes the compliance, and it says, okay, it's 100% or 68%, and we have all the details of what's going on. There will be a demo, so you will understand better what we do. So this is an actual screenshot of Rudder. So we have each of the rules there. So we have a rule to manage administrative account on a Linux server, which is clearly not compliant on this system. It's very bad. The system baseline is fairly okay with 96% of compliance. Grafana is so-so with 80%, etc., etc. SSH hardening is 100%. That's very good. So we can see and investigate what's going on and fix with Rudder or manually if it's something that cannot be fixed automatically. We have a web interface for Rudder, and when we created Rudder, we decided that we needed a web interface. So Rudder was started in 2010, And it was a time where there were Puppet and Chef who started to exist. CF Engine was already there for a long time. And the main problem of configuration management at this time was that it was complex. Managing system is difficult, and learning a language to manage system is even harder. So we wanted to make it easy for everybody, nearly everybody, to manage their system. So we made a web interface so that people could define what they want through this web interface and see what's going on. And the goal is to include as well people that would be the left on the side when configuration management would be set. It was another time, it was when it was very hard to do configuration management. Now it's easier. Ansible made it much easier than it used to be with other systems. But still, with a web interface, you can have people that come, look, and understand what's going on, what is happening on the system. Even a manager can simply come and check that everything is green and say, yeah, it's green. New people who comes to the company can be onboarded and given rights to do first some small things like add new nodes or manage small things, and as their expertise grows, they can do more with Rudder. Everything can be made with a web interface in Rudder. It's the goal. There is no limitation in web interface. You can manage the nodes, you can check the inventories, you can create the groups, you can define your states. So it's called technique, directive, and rules in Rudder. You can check the compliance, you can check your user, who can connect to Rudder and who can access to what in Rudder. You can check also who did what in Rudder. So this is in the web interface, and this is open source. And you can restrict authorization to people to see only some parts of the product as well. We also have API so that everything can be done with the REST API. You don't need to click your way through configuration. You can automate Rudder. There are some companies that use Rudder on very large scale with basically virtually no interaction with the web interface. Everything goes through the API. So they go through their CMDBs to automate stuff with Rudder and get back the result from another medium. You can import, export data between different Rudders, etc. And the access rules also apply on the API. And there is some YAML because we are there. So we need YAML. So the techniques, which is a building block for configuration in Rudder, are written in YAML with a specific language that we developed while writing CIS benchmark, so that we make sure that you can write CIS benchmark with YAML, so you can be with our YAML, so you can do everything you want with the YAML of Rudder to define the configuration. They are stored in Git, so you can synchronize it with your CI/CD and check that your policies are doing effectively what you want before pushing it in production. And the Rudder server compiled this YAML to a language that's understood by the agent. Who wants a demo? Yeah. So this is my Rudder server. This is a demo Rudder server on the cloud, on AWS. When you log in, it's probably too small. Is it better? So when you log in, you get a dashboard that gives you some basic information. Everything is compliant there. I did a great job of configuring my instance on AWS, but I have some nodes that are not correctly updated. This one has some updates that could apply. We will see that after. And we have a menu which is separated in different parts. So the node management to manage your nodes. So you see which nodes are there. So I have 5 nodes. 2 are Debian systems, 3 are Ubuntu systems. So the database, the back There is even a development version for the back office, the front office, and the server, which is called CFG MGMT comp. We have the compliance. I've put also the public IPv4 address so that I know how to connect from that based on this. I made groups based on this node. So I have a group of the back system, of the front office system. So the groups are criteria on inventory. So my front systems are the nodes which have the property app equal front. So it's fairly simple, but you can make arbitrarily complex requests. Like we could check that there are only Linux system or only Debian systems, or with a minimal amount of memory, with a specific software. Like we want to make sure that the front system has Apache to be effectively called a front system. When we get to the detail of a node, we have some information. We know that, okay, the agent ran correctly. It was 3 minutes ago. By default, the agent runs every 5 minutes to check the compliance of systems and correct if necessary. We see in which groups it's part of. We have the detailed inventory, as I said, so the users, the IP address, operating system type, the software, network interface. I will go quickly over that. You can add properties. So I added the property app equal front. You can add them directly in the web interface or with API to export data, to import data, or if you can even export it. And then you have the configuration part. So the configuration is where you define the states for Rudder. So we have a 3-level system with the techniques, which is a low-level part. It's the YAML. So you define what you want to, how you configure something. Let's say I want to make sure that I don't have any swappiness configured on my system. So this is a part of YAML that says, okay, I check the sysctl values and I ensure that the VM swappiness equals 0. And I can override that in a file 99 Rudder if it's not in the main file already. So this is fairly easy to understand. It's only one method that manages sysctl. We can do more complex things like an SSH hardening. So in this one, with OGS, I ensure that in the SSHD config, the password authentication is set to no. So we have a graphical editor which is exactly the same as what's in the visual editor. So this is directly mapped from YAML to graphical. The IDs are added by Rudder. You don't need to type UIDs. And they can even take parameters like for PostgreSQL configuration. I make sure that package PostgreSQL is there, and I define the maximum number of connection and the shared buffer size. And I have 2 parameters for my techniques, the max connection and shared buffer. And then I implement this technique as a directive. And in this directive PostgreSQL, I install and configure PostgreSQL, and I set 80 max connection, 100 megabyte shared buffer. So we can have also forms that are a bit nicer than that. Typically, I created users for myself on every node so that I can SSH on the system if I need to. So I created my own users. So Nicolas Charles, I even set the password there so that my password is known. And I made myself sudoer so that I can connect on the system. And then we have the rules, which is the application of directive to nodes. And I can check for each of them if it's compliant or not. And I can see that, for instance, my user is effectively present everywhere. It's compliant, 100%. I can see that by directive or by nodes on which it's installed. So I have an account of BackDB on BackDB and front. My rules also are used to deploy a company website. So it's a demo website that I made there. Yeah, it's a website. It looks like that. So it's not simply to show that we have a demo, to show that for the demo. And what I will do, I will add a new node within Rudder. I will set it to front group so that it's a front office system, and the website will be automatically deployed by Rudder. Who loves Terraform? Yeah, lucky you. So I will edit my Terraform configuration. And I will add a new node there. Let's say I will add an Ubuntu system. Will Terraform plan. So it checks that everything is okay. And will tell me, yeah, there are 2 new things to add. So let's add them. It will automatically provision an instance on AWS, and with Cloud Init, install the Rudder server, send the inventory to the Rudder server. So it should appear fairly soon on the Rudder server, hopefully. It's still creating. And there it is. I have my new nodes at there. So it should arrive in the pending nodes at some point. It's usually fairly fast. Okay. I will show you something else meanwhile. So what I will do is, when the inventory is there, I accept the node and I will put the property on it front, app equal front with API, and it will automatically configure the website. And I still don't have it. Okay. Okay, so it failed for some reason. See the failure. Let's make another one. At some point it will work. I didn't plan, I'm sorry. One of them will arrive. Yeah, it was the previous one, but okay. So I'm accepting it. Tells me, okay, this node will join Rudder. We can even check what configuration it will have. So it will have the AWS configuration and OpenSCAP configuration to run OpenSCAP. So I accept the node. Yay, I have a new node with a nasty name, but it's not so bad. And I will take this UID to set with an API request the property. I could do that in the web interface, but it's more funny to do that with API, don't you think? Yeah. So, okay. And now it's part of the front group. It wasn't there, it's part there. And I will trigger. Will it work? I don't have a DNS on it, so yeah, it's okay. So within 5 minutes, because it runs every 5 minutes, I should have a company website for it. So let's go back to the slides, and I will show you that we do have a new website on it. So we release a new version of Rudder every 6 months, minor version every 6 months, major version every 2 years, roughly. A minor version adds new features, major version can change significantly many things. We released Rudder 9.0 in October, so a few months back. with a huge focus on compliance, especially around OGS. We can share data more easily. With Rudder 9, we have a CSV export of every table so that people can simply download and show to people, okay, that. We have a new HTTPS protocol for client-server communication with trusted certificates. Yeah, that sounds surprising, but we did not have that before, and it's used in the Secnum Cloud environment and a better templating engine. Rudder 9.1 is scheduled for April with improved traceability on everything that's made. We trace everything, but we trace not so well everything. So for 9.1, everything will be perfectly traced. We will have an improved dashboard with more information, especially who did what change recently, or what are the most offending nodes or most offending configuration, and support for SLES 16. And we have a technique marketplace that should arrive soon, probably April or May 2026. So the goal would be to share techniques. You have a Rudder server, you make your techniques, you can share them, or you can use the techniques that are being written by other people if you don't like to write your own YAML. We have a repository with packages for most distribution on repository.rudder.io. We have a documentation which is fairly comprehensive on docs.rudder.io. We have a matrix chat on chat.rudder.io. And we'll check if we do have a website. No, oh. Okay. We'll still investigate what's the IP address of the system. No, we don't have it yet. So we will wait again. Do you have any question meanwhile, while we wait for the website to deploy? Yes?
Is Rudder thought of as an automation tool in general when you do things like deploying a website with it, or is it mainly focused on security and compliance?
It's used a bit as both, to be honest. So people use Rudder to maintain the baseline of the system over time, and some deployment are part of the baseline. Like when you deploy in EDR, it's also part of the baseline. You want to have your antivirus or EDR, which is there on every system. Website is fairly uncommon, but it's something that you can show effectively during a demo that you have a website.
But it's not planned to go deeper into being like a complete automation platform.
We don't plan to do things like Ansible because Ansible does that very well, but we do have an inventory plugin for Ansible. So Rudder can be used to define on which host you will run your playbook, and you can export a property from Rudder to the playbooks Ansible. So it's quite common to use Ansible and Rudder at the same time, or Rundeck and Rudder at the same time. You're welcome. Okay. Another question, while we wait for the agent to run? Yes.
What about the price tag? Why so fast?
I'm only speaking of the open source part because here we are only open source.
This is the core.
This is the core. I only showed the open source part. I didn't show anything that's not open source.
Yeah.
Yeah. The rule at config management camp is only to show open source. We cannot show anything that's not open source. Okay. Yes?
How do you guys come up with the scoring? If you can elaborate on that, like when you find the scoring, like how, what kind of metrics do you?
So for the scoring, we use several metrics. So we have one on compliance, which is your compliance, everything that has been defined with Rudder, and we have a rule which is roughly, if you have 100% of compliance, you are A. 85 to 100% it's B, and then it goes down to F quite quickly. We have the same for system updates. So if we have updates there is 51 updates available, which are not security, so it's a score of B for system update. So we take the worst score for each of them, and it's fairly visible because when you have systems that are 100% compliant to your rules, but they are not up to date, it's good to know that they are still not up to date because you have probably some risk at running system which have older version of the package. Does that answer your question? Okay. Yeah.
Follows up on this. So like, which source of information do you take? So a lot of tools actually have a lot of code positives, and like, so if like you have this problem with doing assessment with Rudder, is there a way to actually like say, okay, this CVE is not fixed with subscript? So
there is no CVE there, so we only take into account the packages that have updates available. So there is no, there can be false negatives if there is no repository configured. We don't know that they are up to date. We don't know that they are not up to date, but otherwise we don't rely on CVE there. And the demo is a failure. I'm sorry. I sacrificed my knights to the demo god, but it was a failure. Thank you very much.